Hi, today we are going to focus on data scrubbing, also known as data cleaning. And the objective of today's lesson is we would want to define what data scrubbing is. We want to look at the importances of data scrubbing, and then we will do a practical activity in the Jupyter notebook where we are going to focus on data cleaning in terms of missing values, in terms of duplicates, incomplete or erroneously captured information or inconsistent data. Also trying to look also on outlier removal or the identification of outliers. When we are looking at data scrubbing, it is important to understand that this is a process, meaning to say you might be forced to redo the process over and over again until you reach a position or a status whereby the data is in a consistent state or the data is now valuable and at the minimum state whereby there are errors in it. So it is a process of ensuring high quality and complete data is used for data analysis. Data scrubbing is a process of cleaning data and making sure that it is well structured and ready for analysis and even for visualization. It is also important that we try to find the difference between or the gap that is there between data wrangling and data cleaning, because most of the time data cleaning or data scrubbing is also referred to data wrangling, but it is important to understand that these two are different. Data wrangling and data merging, these are bigger processes that range from data collection to visualization, data cleaning, and all the way to data transformation. So when you are looking at data scrubbing, it is a subset of data wrangling or data merging. Data wrangling is an overall framework, while data scrubbing is a component inside data wrangling. Both data scrubbing and data wrangling are part of data preparation process. Why is data cleaning important? It is paramount for us to understand that the machine learning model or the decision that we're going to come up with are as good as the data itself. Meaning to say that if the data is dirty, the data is too noisy, and the data is not clean, inconsistent, there are greater chances that the machine learning model that we're going to develop or to come up with is going to also perform poorly. The visualization that we're going to do to our data, trying to get insights of our data, is also going to be misleading or biased. Therefore, data scrubbing helps to improve the performance of a machine learning model. Data cleansing also helps to reduce the computational power that is required during your training process. When the data is clean and in a well-structured form, it reduces costs such as time and money. When the data is not clean, when the data is dirty, when the data is too noisy, it takes time to train the model. Also, it means to say we will need more space and more computational power. That also means to say those resources need to be taken care of, and therefore it stresses our finance. When data is clean, it reduces chances for making flawed conclusions. You can think of it this way. If your data is too noisy and has got outliers in it, you might find that when you are trying to make a decision, maybe on the average and the mean of the data, it is going to be pushed in a different direction rather than going on the center because of the outliers. When data is clean, it provides an unbiased analysis. So what are we going to look at when we do data scrubbing in our Jupyter notebook? We are going to focus on handling missing value. We are also going to focus on removing duplicates, correcting typos, and also detecting and handling of outliers. The assumption as we go to data cleaning in our Jupyter notebook is that you have managed to go through the EDA process and even the previous uploads that we have done in terms of how to install libraries. The walkthrough of the Jupyter notebook, and just as a prelude to and a reminder to what we have done, if you want to install some new packages, you would want to take maybe, for example, pip install skitline or contact install skitline. Once again, if you have enjoyed this channel, please subscribe to stay updated on the future uploads. Don't forget to like the video and to share your comments, as these are greatly appreciated. Let's go straight away to our Jupyter notebook. So at this point, I would make an assumption that you now know how to upload, to launch your Anaconda and the Jupyter notebook. And as I've highlighted before, I believe that you have also gone through the EDA. So we are going to come up with a continuation of the same project that we're working on when we started the EDA using the healthcare stroke data set. We are also going to make use of the diabetes data sets, and these are found from Kaggle. In our previous EDA session, we looked at how to import the libraries. We imported the Pandas as PD, the NumPy as NP, Matplotlib, PyPlot as PLT for the visualization, and also Seaborn as SN, Scotland import tree, and also we are also going to import the accurate score from Scotland. And in this session, we also want to add the simple importer and also the KNN importer. We are also going to make use of the missing norm, and also from Science Python, we are going to also look at the statistics module. So I'm going to execute the cell. And then the next step, once our libraries have been imported into our kernel, is then we want to import our data set. So I'm going to execute the line to import our data set. It is very important that you know once you have imported the data set, the next step that you want to do is to do an exploratory data analysis of your data set. And this we have covered in the previous session. So we are not going to go deep into it. We are just going to do the simplest EDA of just looking at the data set to visualize how the data set looks like. And these are the columns that are found inside the health data set with the various columns that are there. And we also looking at the dataset.head, which brings up only the first 5 records of the dataset as a way of visualization. As we continue, we also called the columns on the dataset to review and understand all the columns that are available in our dataset. And we also went on to look at checking whether there are missing values inside our dataset by calling isNow function and joining it together with the sum. And we discovered that it was the BMI that had 201 missing records. We also went on to try to visualize and to understand the extent to which the missing values are presented. And calling the MSN matrix, it then shows us that the BMI has got white spaces there, which are positions on which we have got missing values. We also went on to look at the percentage of the missing values and we discovered that we have got the BMI has got almost 4% of the missing records. So this is the position in which we had discovered in terms of our EDA. And once we have now have a brief understanding of what the data looks like and what data types of our data, we then want to go on to the stage of data cleaning. And we are going to check on also fields such as the gender, where we discovered that the gender had another value represented as other gender. And we try to look at dataset gender unique, and it clearly also emphasized to us that we have got male, female, and other as the categories found inside the gender column or feature. So let's begin the scrubbing and looking at how to handle missing values. Since we have now discovered and we now know that the column BMI has got missing values. To handle the missing values, there are many techniques that we can use, but we are going to look at imputing information or missing values by way of using mean, median, mode, constant, nearest neighbor, forward fill or backward fill, and also the drop or remove as a technique. And we are going to make use of the skitline library, where we would want to make use of the simple importer as we have already imported our data. Just as a reminder, we also want to do again ahead to look to see how our data looks like. Now we have got we have refreshed our mind in terms of what the data looks like, it is time for us then to begin to try to solve the issue of missing values inside BMI. So to do that, we are going to start by looking at the mean. It is important that we understand when you are dealing with the mean that you also want, in terms of filling in the missing value, we have to take note of outliers, because outliers have got a tendency of shifting the mean from its position either downwards or upwards. So we have to take note of the mean, the outliers. So what we're going to do is we're going to call the seaborne box plot. And we feed it with our data set, and we are only going to focus on feature BMI. So when you execute the cell, we'll see that if we're going to look at it, there are some other data points that are scattered way above the whisker, and all the way from the 70 BMI, these could be classified as outliers, and therefore they will shift and affect how the mean operates. So it is important for you to check and see that you have addressed the mean, the outliers, before you use the mean to input your data. Let's proceed to working to input the data. We are going to create a variable input, and we're going to call the method simple importer, and missing value, we're going to make use of NumPy, none. And our strategy is going to be the use of mean. And let's effect by creating a new column, and let's call this new column BMI underscore mean. And we are going to use our instance variable, which is an inputter. Then we're going to call the fit transformer, and we're going to pass it fit transform. We're going to pass it to the data set, and we are going to give it a column BMI. We execute the cell. Okay, let's see. Name BMI is not defined. Okay, we are here. So let's define it. And now let's call the data set. And if you check on our data set, that we now have an extra feature called BMI mean. And if we check at row 1 that we have there, at position 1, you see that the BMI is not NA, no data. And when we use the mean, we now have a 28.89. If we also go to another row at 5105. 5105, we also find out that we also have a 28.89. So this is how you would want to input or fill the missing records. So instead of me overriding, if I wanted to override, we would have just removed this underscore min so that we override the value inside BMI. But instead, because I want to demonstrate how it looks like, I've created a new variable that we can use. So let's move forward and look at the median. So this is trying to look at the value that is on the middle. Again, we are going to use similar code. So I'm going to copy it from there and I'm going to bring it down and I'm going to change where we have got min, and our strategy is going to become median. And we are also going to do the same, changing median and then data set. So we execute the cell and then we run the data set and let's preview. So we have changed the strategy from min to median, and if we go to the results, we see that we still have our min and we have added another new column, median. And if we check at the results, the mean had a 28.89, while the median has got 28.1. Meaning to say, if you look at it, both of them are producing results which you can use, which are closer to or in the same range. Another option that we have is also to use the mode, which is the most frequent. And we are also going to use almost the same code, except that instead of using the mean or using the mode or using the median, when we are looking at the mode, we are going to call a strategy called most frequent. Most frequent. And we are just going to change that to mode. And we're going to run the cell. And we call our data set. And if you check at the results, we see that we have also created another column or added another feature called mode. And the results there is a 28.7, which again is in the same range as we look at the three new data that we would want to use to input on BMI. So the choice is yours as you are trying to work around ways of cleaning your data. You will find that there is no one answer in terms of data scrubbing. It is based on what you intend to achieve, and remember, it is a process. So you keep on adding new data, you keep on cleaning, and as you try by all means to make sure that your data is of high quality and free of errors. Another method that we can use is to use a constant value. So depending on the question the problem that you are solving, you might also want to, that determines what the method that you would want to use. So we are going to say constant. Here we are just saying that instead of you trying to calculate, you have got a specific value that you want to be inputted across all the whole column. So what we are going to do is we then want to call a strategy called constant. And then we also want to pass the value that is going to be used to fill the missing value. And let's say we are going to use 26. And let's change here to constant. We execute. We call our data set, and you will be able to see that again we have created or added another feature, and every time a missing value is found, it's going to use the value that we have specified is going to be used. So this is a missing value, and this is another missing value that has been added or created using a constant. Another method that you could use is making use of the k nearest neighbor imputer. And we are going to create again a variable called imputer, and we are going to call knn imputer. And we are going to specify the number of neighbors, and let's say 2. And we are then going also to create a new column or feature, and let's say BMI and NK for k nearest neighbor. And let's call our imputer dot fit transform, and then we pass through our data set, and we also want to pass our BMI. We execute, and then we call in our data set. We execute, and let's put a dot header and specify 4, 5. And if we are going to go to the new created feature, you will see that where we have our BM missing, it is also created based on nearest neighbor is a 28.8, which is closer to the mean that we have. So this is how you would want to use your k nearest neighbor approach. Another method that we want to look at is what we call the forward and backward fill. Here what we are all talking about is that you would want to use the backward, which is the previous value that is in a previous row. You use it in the row coming after, which is missing, or you would want to use the value that comes after the missing value as you move backwards. So to do that, let's say data set, create a new value and a new feature. There we are going to call it BMI fill for forward fill, and we are going to pass in our data set. We pick our column, and that's our BMI. And then we are going to use a method called fill NA, and the method that we are going to use is called fill forward fill. you'll find that it is the same as when we are doing backfill. So instead, let's just change the variable there to backfill, and the method that we are going to use is backfill. So we execute the cell, and then we are going to call our data set to see the results. Let's call the dot header. And let's go and check the results. So when we are using the backfill, it takes from the previous available, the previous BMI, yes, yeah. It takes from the previous value and is going to be used on the missing value. And if we are looking at the backward filling, it looks at the one that is in front of the missing value and is going to be used backwards. That's how you might also want to deal or to handle the missing values. Now let's look at handling typo errors or inconsistent data based on typing errors. Handling typo errors or inconsistent data. So let's scroll to the top. And here what we are going to do is we are going to focus on the replace method. And also we are going to use the map method. There are many methods that you are able to use, and there is no one answer fits all or the best answer. So it's all about a process of cleaning data using various techniques over and over again until you have reached a position whereby your data is of high quality. So we are going to recall our data set and dot head, and that's our data set. And let's look at gender, data set dot gender dot unique. And when we call the gender.unique, we see that it has got 3 values there. So we would want to handle the errors that we feel that the other should not be there. Rather, we want to remain with male and female. And we have now discovered that we've got the other. So how are we going to handle that? Let's work with, let's say, new data set, and then we call our data set, and let's call our column data set. Let's pass through our value, which is gender. Let's check if it is equal to other, and let's bring our new data set. So when we try to check to see the records whereby the gender has got an other, we see that we have got one record there which has got a value that is outside the male or the female. So when we look at it, depending on how big the data is or depending on our data set, we might choose to just drop or remove the row completely since it's only one. But there are circumstances whereby you might want to keep the volume of data, and therefore removing the record will not be an option, but you will need now to input the data by way of changing or manipulating it. That's when we now can use the replace method or the map method. So let's use the replace method. So we are going to say dataset gender dot replace and we call a method to replace, and what we want to replace is other, and what is the value that we want to use for other. Let's use male for that, and we want to do that change in place, meaning to say in the same data set that we are using. And then let's call the dataset .gender .unique to see if we have managed to change or to correct the error. So if we run the cell, we are going to see that now it returns an array where other has been removed, meaning to say we have replaced the value, this row, which I did other, with the map. So we have imputed it by a direct method of imputation. Another method that we can use is the map function. And to use the map function, what we are going to do is we want now, because we have already replaced this with a true inline, so we need to call the original data set where we uploaded the data set. So I need to repopulate with the original source, our data frame. So we come back, repopulate again, and now we are back to the original data set. Let's we have seen the data set. Let's call the dot header. Okay, so we are back to the original data set that we started with, and we now need to replace the typo error or the capturing error. As we can see there, we are back where we have 3 values with the other, and we want to deal away with the other. So what we're going to do is we're going to say gender mapping assign. We are creating a map. So let's say we're male, and we are also going to be changing, instead of keeping the male, I'm also going to do something like an M, and let's do female. Let's change that to F, and where we have other, let's also change that to male. So this is a mapping that we are creating. So we execute that cell, and now let's go to and change the data set, and we are going to call the gender, and we are going to fill the gender column or feature with gender. Now we call the map function, and we are going to use our mapping that we have created, and then we call our dataset dot. Instead of calling it, let's just execute the cell. And now that we have executed the cell, let's check to see if we still have unique values inside there. And when we now type unique, you can see that we have changed from male to M because we have mapped where male is found, put an M, and where female was found, put an F, and where other is found, put an M, meaning to say now we have managed to map our fields by replacement. So this is how you would want to handle data where it could be inconsistent or captured by an error, which you can quickly discover that this is an error. In terms of cleaning, we also want to look at how you can handle duplicates. So duplicate. So to check for duplicate, you call your data set and then you call duplicated as a function. And if you run it, it's going to check on every row, telling you if there are duplicates or not. And we are going to add a sum also then. And you can see that there is no record that has got a duplicate in a way. So in the event that your data set has got duplicates, that's how you would want to identify the duplicates. And a way of handling the duplicates is you might want to just drop them because you already have the data. There are various options that we have in terms of which data to drop, whether you want to drop the first one or to keep the last one. So you would want to call the data set drop duplicates. So I'm going to run the cell. It's not going to do anything because there is nothing that is missing in terms of that is duplicated. Another function, another way of cleaning is about detecting outliers and then finding ways of handling them. Outliers. So there are many techniques that you can use in terms of identifying outliers. Some of them, let's say the box plot. You can also use the scatter plot. This is by way of visualization. You can also use the distribution plot. And then you can also use z-score. You can also use the interquartile, quartile range, IQR. And there are various techniques that you can use. Let's just try to see how we can use some of those. So if we are going to use the box plot, in this case, what we want to do now is to switch from the data to use dataset 1, and we are going to read a new dataset, read CSV, and we want to use the debits .csv and call dataset 1 .header. Put an error, it's coming from there. Right, so we have imported a new dataset, the diabetes dataset. We will now want to see if there are outliers in this dataset. So let's go ahead and use the box plot. Let's say box plot. So let's create the box plot. And we pass through the column dataset. We are using dataset 1, and let's call the BLI. And let's check the results. So we call our box plot on column BMI, and we are able to see that using the box plot where the whiskers end there, we still have values or data points which are above and below, way below the whiskers of our box plot, and these could be classified as outliers, and therefore we need to deal with them before we start manipulating and doing some visualizations. Else they will bring in some way of bias. Just as another way to represent that, you could say sample dataset and BMI using the Matplotlib box plot, and then we call our sample. We call that and false, and then let's just plot and show. Okay, we have got an error. Its BMI is not found. Okay, we need to use dataset 1. Let's run, and again we have got a variation of that, and again we can still see that we have got a data point that is outside, or that are outside the whisker. These are the data points that we might classify as outliers, and therefore we might need to handle them or remove them or keep them some way, depending on how you would want to do, and also the size of your data set. We can also use the interquartile range. And when you are dealing with the interquartile range, let's create outlier variable, outlier, and let's create a function detect outliers, interquartile range, and we make the method or function to accept the parameter. So let's say data is equals to sorted data, and Q1, let's call the NumPy percentile, and we pass through the data so that we get the first quarter, which is 25%, and then we also call the third quarter, again using NumPy dot percentile, and we also pass our data, which is a variable containing information, and we are using the 75%. Let's print, say print, let's say first quarter. Let's say first quarter, and let's print Q1. Let's do third quarter and print Q3, and then our Q range is equals to Q3 less Q1. Then we want to find some lower bound, and we say Q1 minus 1.5 multiplied by interpreter range. Let's change to upper bound. And this time we are using Q3, and instead of slashing we are adding, and let's print lower bound and let's do the same for the upper bound. Now let's look through the records for I in data. What we want to do is now check if I is less than lower bound, or if I is greater than upper bound. And if it is lower than the lower bound and it is upper, or it is upper greater than the upper bound, that means it is outside of the whiskers. So therefore we want to collect that data, and we say outliers.append I, and then eventually we want to return the outliers. And let's see how then we can use, let's say, sample outliers. We now call the detect outlier, and we pass through the values that we want it to have, and we are going to pass through our BMI, and it's going to return the sample in sample outliers. So let's print and say F numbers number outliers detected, and replace the length, let's say detect the length of sample outliers. Let's see how that goes about if we run it. What cannot concatenate string and float. Okay. Let's see how it goes. Okay, let's just remove that and let's execute the cell and print. Can only concatenate strings, not float. Okay, let's check what we can do. This time is on the float, so let's remove this and let's see what we have. Execute. Cannot concatenate string. At which point BMI. Dataset 1. Let's remove that as well. Execute that, execute the remaining. Okay, so and if we're going to check there, we see that when we first do the first print, which is Q1 of the first quarter, it gives us 27, and then we have got the third quarter being 36. We also went on to print the lower bound and the upper bound, and the lower bound being given as 13.5, while the upper bound is being given as 50. And then we said retain, print the outliers, and when we print the outliers here, it gives us 19 outliers that have been detected. So then we want to replace these outliers. But before we do the replacement, we might also want to do a visualization using the scatter plot for just a quick review of the same data to see how it looks like. So we say was at this position, we are still just detecting any scatter plot, any outliers. So this is how you might want to identify outliers. So we're going to make use of the Seaborn library, and we call the scatter plot, and then we call in the data, and our data is dataset 1, and then we want to pass the X value is dataset 1, and we are going to call in the BMI, and let's do the Y, dataset 1, and we might also want to call in the relationship, let's say age, and let's say the U, and let's pass through dataset 1 the target variable, which is outcome, and let's see how that looks like. Okay, so we have plotted the scatter plot on the same data, and clearly we can see that we have got a concentration of BMI points from the somewhere between the 15th and the 50th, points there, and we have got these which are on the far on the 0, and also some of them that is about 50 there, and therefore by clear visualization we can see that these might be outliers which are on the lower part and also on the upper part. So now what remains is to identify at what point you would want to trim out or to replace, remove, or drop the outliers. So as you can see, we are in visualize that we need to drop anything that is maybe below 10 and anything maybe that is slightly above 50 according to this scatter plot. According to the interquartile, the upper bound is a 50, so anything that is above 50 could be referred as outlier. But again, like I said, it's not about you fixing to what you see there, but it's about you using your skills to clean your data. So you might not want to go straight on 50, but you might want to go a little bit higher as you do your cleaning. And again, if we are going to use the box plot, which is a clear visualization, again, you can see that anything that is below something like 5 there is an outlier. And anything again on the 50, which is where the whisker ends, again, it could be an outlier. But however, you could say maybe these ones, they are too close, and then maybe you could start at 55 or 60 in terms of dealing with or handling your outliers. Another method that you could use is the Z-score. So let's just quickly try to see how we can use the Z-score, or maybe let's try to remove the outliers, to handle the outliers. Remove the outliers. Let's remove the outliers for now, so that we'll keep our video a little bit shorter. And what we're going to do is we're going to say dataset one dot drop, and we are going to drop dataset one where our BMI is greater than 50, dot index, and then we are going to do an in-place place. It's not giving me the option. Something could be missing. Let's check dataset one. If we say drop dataset, and we might want to open bracket and call dataset one, and then from there we can close the bracket somewhere here, and we then call in place. It's not coming again. What are we missing? Okay, let's run it. We'll see the code, the error code as it comes through, and we are going to do the same for the lower bound, where it is smaller than let's say smaller than 8. Let's see if we have a code. Okay, there's a mismatch in terms of our brackets there. So let's start drop dataset 1 and dataset BMI is less than 50. It's less than 50. Okay, execute that now. Now it's working. And let's now do another scatter plot to see how it looks like. Cbone.scatterplot, and let's call the data set 1. Data set 1 is our data, and let's specify the x is data set 1, and we are dealing with BMI, and let's call in our y is data set 1, and we are now dealing with h. Let's see how it looks like as we compare the two. So if you check now, we have managed to do away with anything that was below 8 to 0, and anything that is was above 50. And to say now we have got a concentration on the center. So that's how you would want to handle outliers. You could also go on and do the z-score. We are going to do a z-score on a separate video so that we keep this one short. So this is data cleaning. You would want by all means to make sure that your data is at a highest position of quality and also in a good structure in which you can do some visualizations and also feed to the next process inside our pipeline of machine learning, which is called feature engineering. Ladies and gentlemen, if you like this channel, remember to subscribe so that you won't miss the next uploads, and also kindly like the channel. And I would want to know what you think about data scrubbing, and if you have got any other technique of data cleaning that you would want me to look into, please drop in the comment section so that I will upload it for you. Cheers.